Hi friends, today let's talk about uh, builder design pattern. Okay, let's see. Let's first go the motivation behind creating this builder design pattern. Okay, and why this builder design pattern is required and why we are using this. First, let's build the motive behind this builder design pattern and what are the problems associated to this. Okay, so if you see, there are different problems um, behind this builder design pattern. So the first problem is basically imagine if you have a constructor. Okay, let us say assume you have something called a class called class database. So in the database basically you have some fields called you have something called host. Okay, some port. Okay, so you have some name. Okay, some id. Okay, and some username and password. Let us say these are the fields. Okay, so now the problem here is, okay, if you want to create a constructor for this. Okay, let us say you are creating a constructor. Okay, some local host you're creating. Okay, some port you're giving, name is some Ravi. Okay, some id, let us say some 22. Username is something called admin, and test 123. So these are the fields. Okay, assume these are the fields which we are creating. If you see this constructor, so there are a lot of parameters for these constructor, right? If you see, if you see, there are a lot of parameters for this constructor, which makes this constructor not maintainable, right? So it looks ugly. Okay, that is a problem. And the next thing is, for example, imagine if you have some scenario called new database and you are passing some username and password. Okay, you are passing something like this. So let us say both are strings. So this is also a string and this is also a string. Now you can also pass like this, right? You can also pass password comma username, because even if you pass it in the wrong order, this accepts, because ultimately you're specifying this as a string and you're not basically validating whether this is basically username, or this is basically a password. Even if you are passing in the wrong order, it is not validating and it is not maintainable basically. Okay, so this is also the biggest problem. Okay, the maintainability problem when you're having much long constructor, and also you can also pass in wrong order without any validation, simply you can pass whatever you want. So these kind of things are the main problem. Okay, so that is the first problem which we see. Now let's go for another problem. Okay, Imagine uh, imagine for the same class database, you also have something called DB type. Okay, type. So now this person, let us assume you have a user, and the user type can be something like student or mentor. Let us say for a student you have something called badge, problem solving percentage, PNSP. For a mentor, basically you need to see the experience and the company. Here you clearly know what is a type. So the user type, it could be for a student type or it could be a mentor type, right? But imagine if there is no type. Imagine if there is no type, if there is only a user type. Imagine if there is only a user type. You don't know which type you want to send, right? So it could be a student, it could be a mentor. You keep on keep on overloading the constructor, which leads to a telescopic or anti pattern. Got it? So uh, in these scenarios, I mean, the user type, if we know the user type, then it's okay. But if you don't know the user type, then basically you're basically passing different types of different parameters to the user, depending on each other. So one may be dependent on one, and another may be dependent on another, so which basically leads to the telescopic pattern. So if you see this, it leads to basically a telescopic pattern. So what I'm saying is, basically you don't know what is the user type, and simply basically you're passing one constructor to the another, and another to the another, because one is depending on another, and consequently this depends on the above, so it keeps on moving forward. Okay, so that is a problem. So the maintainability is the problem here. So this leads to anti-pattern. So nothing but the telescopic pattern. Okay. So that is one issue. Okay. Because if we are not specifying the type here, right? So one may be dependent on, so because if you have types, like in this case it could be a student or it could be a mentor, one type could be dependent on another and another could be dependent on another. It keeps on adding and it's not maintainable. So that's the main thing. And one more problem is, let us say you have some values here and you are basically validating here. Let us say you have a constructor and basically you are validating it here. Okay, so in this scenario you're calling a constructor and you are validating it. So the problem here is, you need to validate before you call the constructor, because what do you mean by calling a constructor? See, let us say you have an object called database. Okay, what do you mean by calling a constructor? Let us say you have an object called database. Okay, so what do you mean by this? Okay, when you are saying new, first when you are creating a DB, it will create a reference variable, right? a reference variable, and when you're specifying new, it will create a instance with some address, and this address will be pointing it to here. So whenever once this instance has been created, and once this instance has been created, then it will go to the constructor and it calls and it will initializes the default logic, whatever it is. Okay, and once the initialization has been finished, then it points to this reference, whatever it is being added. So this is the process of object creation. So in this process, during this process of object creation, before creating an object, you need to validate the fields, right? So without validating the fields, if you're creating an object, it may fail while creating an object, right? So it's not a best practice. So before creating an object, it's always good thing to validate it. But in this case, what you're doing is, after initializing the database, the process of initializing the object, you're validating it. So this is wrong, right? So this is another problem which we are facing. So now coming to the main problem. So this is the main problem, the final and the ultimate problem. So listen carefully. Okay, so one is basically a default construct. So that is the main thing, and setting values using setters and getters. Let us say you are setting the values. Let us say your set host. You're basically telling you're setting the values like this. Okay, sorry, this is some local host, and let us say this is 4422. Let us say db dot set name some name dev db. So now you're basically setting the values using the setter methods. Okay, now the problem here is, okay, okay, now the problem here is, whenever you are setting the values like this, okay, imagine if this is an object and you are setting the values of host, port and type, right? Okay, whenever you are setting the values using getters and setter methods, first it will set with the default constructor, default CTOR. Okay, so first basically what I'm trying to tell is, first it will try to so in this P4 problem, first you're telling default CTOR, and second thing is you're setting with these values. So now when you're setting with these values, the first thing is it will initialize with the default constructor. Okay, and the next thing is it will try to set values. Okay, let us say somebody is adding a value here, and somebody is adding a value here, and somebody can add more values here. So if you see, whenever you are basically calling these setter methods, you are basically mutating the objects over different periods of time, right? So basically you are mutating the object. When you are mutating the object, right, there is a problem here. Okay, let us say you have, in a real-time scenario, let us say you have some value y, some value y equal to 1. Okay, and you are passing this object to different classes. Let us say you are passing to controller class you're passing to some repository class and you're passing to some service class in a real-time scenario, let us say. So ultimately you need the value as y equal to 1, right? So you are passing it here and you want this y equal to 1. You're going from controller to repository and from repository to service. But what happened here is, imagine somebody has changed this value from y equal to 1 to y equal to 2. What will, so this will impact the output, right? So when when you say the object is mutable, the value will be changed at anybody can change the value at any point of time. So since this object is basically a shared object and it is being used across different parts of the backend services like controllers, repositories and services, if you are changing the value in between, there is no guarantee that the value is consistent. So you cannot basically predict who changed the value. Basically you need to keep on polling and see who changed the value, right? Because object is mutable, so anybody can come and anybody can mutate the object, right? So in order to avoid this, what we are doing is, instead of going with setters and getters, we only prefer the constructor based object initialization. Okay, so so we never go with setters and getters. If we go with setters and getters, we don't know who will change the object at any given point of time. We don't want to take that chance. Okay, whenever there is a change in the object, we want to create a new reference. For example, let us say this is the state 1 of an object, and let's say this is state 2 of an object. Let us say 0 1 1 2 3 and let us say 0x 1 1 2 4. So this is the new reference. This is the first reference and this is the new reference. Let us say we have x equal to 1 here, and let us say you are changing y equal to 1 here. Sorry. Let us say you have a value of y equal to 1 here and you are telling y equal to 2 here, right? So whenever you are changing the value from y equal to 1 to y equal to 2, you clearly know that there is a change in the reference here. So the reference value has been changed from here to here, and you will get a be clearly notified that whenever there is a change in the state of an object, the reference gets changed, because you are saying you are making the object as immutable. So this is the biggest benefit, because you are making the object as immutable. Just with the reference, you don't need to worry about the internal values. Let us say tomorrow you have let us say for an object you have x1, x2, x3. Okay, let us say x1, x2. Simply one, let us say two values are there, and tomorrow somebody is adding x1, x2 and x3 also somebody is adding. So it will create a new reference instead of modifying this reference. You got my point? So there is no need for there is no need to continuously. So if you make the object as immutable, okay, if you make the object as immutable, you can just compare the new reference with the old reference and simply check the diff. You can basically check the difference between the new and the old, and you can say what is the change which has been affected from the old object. But if there is no, but if there is if you are mutating the object, okay, let us say here they have two values, and somebody is mutating the same object, okay, for the same reference. So you have the same reference here, 0x, sorry, you have same reference here, 1123, 0x 1123. Okay, okay, every time you need to keep polling what is the value which has been changed within this object. Every time you need to poll the same object to check what has been changed. So this is the biggest drawback. Okay, so in real time scenarios also, like in React and all, let us say you have a form. Okay, so you have some values and you have submit button here. Okay, and whenever there is a validation errors here, immediately there will be a notification saying that this validation has been failed. How in React this was able to achieve is based on immutability concept. So they cannot simply keep on checking the same object again and again to see that if there is a change in state. We can, of course, we can do that. The problem is there will be there will be much the time consumption, the performance will be impacted because you need to completely keep on polling. But if you are saying, if you are saying the object is immutable, simply when you change the reference, you can easily compare the old with the new one, and you can easily make the diff checking. The diff checking will be much more easier. But there are also drawbacks to it. I'm not saying there is this is perfectly fine. Okay, there are also drawbacks to it, because if you're creating a new object, there will be the memory footprint will be more, right? But the overall, but if you see the overall performance wise, then even the immutability is only the best concept, because you're clearly checking the differences, right? So that's the main thing. Okay, I hope these different concepts are made you understandable, and this better way for this builder design pattern. So if you can review, we have come up with the motive of why we are using the builder design pattern. We came up with the database class and how the constructor creation is whenever there is a big constructor, how there is a problem in maintainability of that constructor when there are a lot of constructor, and how the parameter mismatching can happen if you are making it as generic, and if there is any and if there are any types involved for the user, then also then there is a problem with the dependencies, right? Which leads to anti pattern, because if you are one type may be dependent on the other type, another type may be dependent on another. This leads to basically a telescopic constructor design pattern, because all these constructors are dependent on each other and you cannot basically predict, right? So that is the second problem. And the third thing is validation problem. So whenever you are doing a validation, you need to make sure that you have done the validation before creating a constructor. After creating a initializing a constructor, you should not do the validation, but you should do on before, so that if there is anything fails also, it fails on at that point of time instead of failing while initializing the constructor. So, and the fourth and the final problem is the main problem, which is nothing but the immutability concept. Immutability concept is so when we are creating a default constructor, whenever we are setting the values using the different using setters, so the object can the object initialization can be very risky, because anybody can change at any point of time, and we need to continuously poll that same object to see what values are changed over the period of time, instead of comparing the new reference. So that is why we came up with the concept of immutability. Whenever we say there is an immutability, whenever there is a change in the value, it simply create a new instance and compares the difference of the original values of the object. So in a way, it becomes easy for checking and maintaining the state of an object. So this is much used in React, because React every time it involves in checking the state of an object, because whenever there is a validation fail, or whenever there is an event which is being occurred in the React DOM, you need to basically get a notification saying that there is a change in the state of an object. So whenever there is a such in such scenarios where you know, where there is a lot of state involved in manipulating the DOM in frameworks like React, you basically need to get a notification instead of completely polling and checking, right? Because these are basically event driven models. So these React DOM and these DOM events, what you call validation errors, or some notifications, or these callback events, all these need to be handled via the notifications, and accordingly you need to check the state, because you don't know which event will happen at what point of time. Right? So these are basically event driven models. So that is the reason why we go with the immutable. So immutability will be a big plus for this. Even though if you are creating number of objects, I know there is a drawback that there are number of objects being created, but when you are saying it immutable, then you are basically checking the state. Okay, so that is the main topic behind this builder design pattern. I hope you enjoyed this video, and it has provided more insights for you. Yeah, thank you, and thanks for watching the video. Good.
So hi friends, now let's talk about the code base of the builder design pattern, and let's see what are all the problems associated to this builder design pattern. Okay, and let's talk about the problems one by one. Okay, so I created a sample of the problems, and also I have created a unit test associated to that specific problems. So this is the one which I have created it, and so if you see the problems which we discussed in the motive section, what are the different problems associated to this, and to this builder design pattern, and okay. So if you see this database class, we have different props, and we have a getter and setter methods, and we have a default constructor, and we have a parameterized constructor. So initially when we discussed about this parameterized constructor regarding the maintainability of this constructor, if you see the props of this particular constructor, we are basically validating the props here. So if the validation fails, basically we need to throw an exception. But is it the right way to do the validations at this point of time? No, right? Because the validations needs to be performed before instantiating and initializing the object. But in this case, the validations are being performed right at the point of initializing the object. So this is wrong, and so that is one problem. And second thing is the telescopic pattern problem which we discussed, or the anti pattern. Okay, so if you see this the other constructor, this constructor is basically dependent on this constructor. So if you see, there are three parameters: host, port, and type. And along with this host, port, and type, we are also sending the name and password, and we are initializing the values to it. And it basically depends on this particular piece of constructor where it sends this, where it initializes the values here and sends the remaining parameters which are being passed here. And coming to this constructor, we are having only the database type, and we are inheriting the remaining parameters from the previous constructor, and also we are initializing the values here. So the inheritance of the different constructors and the dependency of the of different constructors makes this as an anti pattern, because it is not basically the maintainable piece, right? So tomorrow somebody can add a new constructor, and he can create a separate dependency there, and where the chain keeps on growing, and it kind of like forms like telescopic, right? It's, if you see the example which we have explained before, so initially the base constructor and the constructor size keeps on decreasing, just like a, what you call, the ice cream cone. Okay, so that's the problem. The second problem is, and the other way, what we thought is, the other way what we can do is, with this um, so with this, for this class, we are trying to initialize the value using the dictionary. So when we are whenever we are passing the values, and when we are trying these values, we are trying to initialize with respect to the values which are being populated from the dictionary. Then the props, basically we are trying to initialize from the dictionary, and this particular dictionary, if you go to this unit test, this particular dictionary, we are trying to pass the objects. So we are trying to add the values here, and once we add the values, we are trying to target it, pass it to this particular constructor. But if you see the problems here, so these are basically a hash map, and we are passing a key and key value based props. So in hash map, how does one know which key to send? We don't know which key to send, right? So how can we initialize this kind of format? Okay, so this is also one of the scenarios where we fails. These are all different problems which we are trying to explain, and how to initialize the object, how how this fails on different levels. Okay, so this is also one of the problem. And the second problem is, when we are trying to add the ports, it will get the casting exception, because if you don't know the type, it may fail, because C# is strongly typed, right? It may fail at this point of time as well. So that is the problem here with respect to this dictionary type of initializing the logic. So first is the default constructor, and second one is we came with the parameterized constructor, how those are dependent on each other, and now we are trying to come up with this dictionary type of initialization. So that is also one of the drawbacks of how the initialization. And one more thing which I forgot to mention is, when we're trying to so if you see here, we are trying to initialize the object, instantiate and initialize the object using the default constructor, and we are trying to set the values. So and again we are trying to mutate the object. So mutating the object is not allowed, right? Because if you want to mutate the object, you need to mutate the object based on certain plan. Okay, so that is where the builder design pattern comes into the picture. So you cannot simply keep on manipulating the mutating the object. So if the constructor grows, so in this case, since this is a small values, we are trying to initialize this. But if the constructor keeps on growing it, imagine how the initialization problem, how the mutation problem keeps affecting on different levels. Basically, if it's a kind of like a shared object for across the application. So that's the problem. Okay, and so to consolidate, so it's not so that we need to basically check the type safety using the props, and second one is immutability. Also we need to check, and also we need to validate before constructing, and also the fourth thing is make sure this is basically an on demand. So we need to create the object based on the customer demand, but not in simply keep on adding these constructors and kind of like initializing the values. And one more scenario which I thought of covering here is, so we can also pass the parameters into this constructor, and we can initialize this. But again, we are to initialize the params, again we are passing the object, right? So to solve the, basically our intention is basically to solve the object initialization and object creation process. But in this case, to solve this object, you are passing one more object. Again, to solve this, will you pass one more object? No, right? It's kind of like circular. We keep on going the circles. So if you so these are all the different problems. So how there is a type safety problem, how the mutations are being affected. So we should make sure that it is immutable. How to validate it, and how to construct the object on demand. So that is where this whole builder design pattern comes into the picture. Okay, if you see here, so these are the different things to initialize the object, instantiate or initialize the object. This is the perfect way. The first thing is hiding the constructor. So we are basically hiding the constructor. And second thing is we are creating an inner class with the same field as the outer class. And third thing is create a fluent interfaces for setters. So why these fluent interfaces? These fluent interfaces also provides the initialization of the props and also validation of the props. And fourth thing is finally building an object. Before building an object, we are also validating it again. Okay, if you see here, we are also validating it, and finally we are building the actual object, okay, which we are trying to construct and pass the props and construct it here. So this is the final step. Okay, so these are so in this case nobody can create an object just like that, because we are making it private. The constructor is made as private, and also the props which are being initialized or which are being created and initialized are also being done systematically. Okay, since we are hiding the constructor, the only chance for any person to create an object and initialize the object is basically to call this class and to access this particular helper class. So if you see here, so this is where we are trying to do all these things. So first thing is, what we're doing is we're calling the class and we're trying to call this builder method. So where is that? So this is the builder method, which in turn gives you this helper class, and within this helper class basically you're trying to do a fluent validations on these props, on this particular props. Okay, and finally you're saying it only after validating it, remember. Okay, only after validating it, finally you're building the object. Okay, so that's where the whole thing comes in. These are just so I have written these scenarios basically to see whether this object is null or not, and also make sure this database name and these things, basically to make sure these assertions are passing. So this is basically a builder design pattern. So if you to summarize, so initially we came up with how this builder design pattern, why we are basically coming up with this builder design pattern. So builder design pattern basically solves the problem of handling the constructor or object creation or object initialization effectively, and keeps the process maintainable. Okay, so these are all the problems which we saw initially. To avoid these problems and keep the object creation and initialization much more maintainable, that's where we came up with this builder design pattern. And initially, if you see how so if we are making it public, and also we are allowing to pass more parameters, and also the validation, the way we are passing the parameters, in which different way we are passing the parameters, and how this telescopic pattern is also kind of like affecting the initialization of the object. And also, if you remember, initially we discussed about the order of passing the parameters. Here we are seeing the name and password, and also instead of name and password, somebody can also pass password and name, because there is no validation here. Simply somebody can pass anything just like that, because this is a public constructor. And also how the dependencies between different constructors, and also and the second approach is basically we thought of creating initializing the object with respect to the dictionary class, and how the dictionary class affects, you know, while validation, while type safeties, and also which props we need to send, because that's basically a dictionary. And finally, we thought of again passing the as a params in the constructor, but that's also a problem, because to solve that we are basically passing one more class. Again, to solve that, do we pass one more class? That's kind of like a circles, right? Because first of all, we should not allow someone to create an object on a first place. So that's where we came up with this private, right? So why we came up with this private is we don't want somebody to create an object just like that. Okay, so I hope these insights are very helpful, and we have explored you know very much deeply, and I think nobody covers this much deep. So my intention is basically to cover the practical scenarios which I have learned from different sources, and just wanted to present it. Okay, so I hope you enjoyed the video. Thank you.